So we've looked at the mean as an important measure of center. And now we're going to turn our attention to an important measure of spread called the standard deviation. Okay, now the standard deviation is also an average. That's something that's not ever brought up, but it's an average. It's an average distance that your data values are away from your mean. Okay, so when you're describing a data set, there's really two important statistics that we're going to want to look at. One is the center. What's the center of that data set? And the other is how spread out are the data around that center. And so now we take a look at standard deviation to understand how we can talk about, using a numeric value, talk about the spread of the data around the center. Okay, so I put in bold here that it's the average distance the data points are from the mean. We're going to kind of ease into the calculation. And before we do the standard deviation, we're going to compute what's called the mean absolute deviation, because that is a kind of a more intuitive way of thinking about an average spread or an average distance from the mean, even though it's not the one that's commonly used. So we'll take a look at that in the next slide. Okay, so here I have some data values for the maximum speeds of roller coasters. So I've got 8 roller coasters, and I want to find the mean absolute deviation of this data set. So I've given us a table as kind of a scaffold to help us do that. The first thing we'll do is just list the data values here. So we've got a 58 miles per hour, an 88, a 40, a 60, a 72, a 66, an 80, and a 48. Okay, the next thing we're going to want to do is find the mean. So if we add those up, and divide by 8. I've done this ahead of time. I believe you get a 64. Okay, so there's our mean. So we're going to just copy the mean down in every single entry next to our data values. Okay, so I've got my data, I've got my mean. Now I'm trying to calculate an average distance that the values are from the mean. So we're first going to do find what's called the deviations. So the deviations is nothing more than the data value minus the mean, and it includes sign. So 58 minus 64 gives you -6. So I'll even put the minus here just to remind us the direction we're going in. 88 minus 64 is 24. 40 minus 64 is -24. 60 minus 64 is -4. The next one gives me an 8. I get a 2, 16, and -16. So those are the deviations. Now, you would think that maybe we should just average those, right? But if you look closely, when you average them, you'd have to add them all up and divide by 8. But if you add them all up, they just cancel. You get 0. In other words, this -24 would wash with that 24, this -6. This 16 and the -16 would wash out. This 8, 2, -4, -6 would all add up to 0 as well. So that doesn't make sense, because we wouldn't say that the average distance these roller coaster speeds are from the mean is 0, right? Every single data value is a distance from the mean. So what we want to do is we want to think of the word distance in terms of how we think of it in everyday life, right? Distances are positive. We don't say somebody's -5 feet away. We just say he's or she is 5 feet away. So we take the absolute value of the deviations. In other words, throw away negatives. Okay, now this, we can add these all up and we don't run the risk of getting 0. So if you add those up, you get 100. You can check. And there's 8 of them. 100 divided by 8 is 12.5. Okay, so I'm not going to belabor this point. I just want to write what that 12.5 means. So this means that the data values differ from the mean by 12.5 miles per hour on average. Okay, that's an average distance. That's what that word differ is implying. That's the average distance the values are from the mean. So for reasons that have to do more with mathematical properties than anything else, we never really use the mean absolute deviation, even though it makes sense. The thing to point out is that the way we got rid of these negatives was that we took the absolute value, right? So that the problem was these negatives. So there are 2 ways to get rid of negatives. One is absolute value, which we've done here, but another is to square the numbers, because when you square numbers, all negatives become positive and positives stay positive. So I'm going to just write here, we could have squared we could have squared. Now when you square, you make things bigger. You can undo that by square rooting. So you're going to see that the standard deviation calculation involves squaring to get rid of the negative, not taking absolute value. But then we have to sort of undo the squaring by square rooting. And again, it's really just used because it has good mathematical properties. The other thing is most of the time your calculator is going to do this anyway, so I'm just sort of revealing the calculations to give you a better sense of what we mean by a measure of spread. So this is just a visual again of the calculation we just did. Kind of gives you a nice layout. We found that the mean was 64 here, so 64, and you can see that the data values differ around the mean. Right, they're on either side of the mean, those data values, and we noted that if you add up all the distances with the negatives included, you would get 0. But there's no way that the average distance these data values are from the mean is 0. So taking absolute value and summing takes care of that.